Hello. Let's see how we can reduce the dynamic behavior of a building using seismic isolators. Help the channel by leaving a like. Seismic isolation tries to break the dynamic behavior of the structure with respect to the ground. Therefore, the two rigid planes must be separated. And for that, insulators must be placed between both planes. Referring to the response spectrum of the terrain, of a given seismic zone, rigid structures have a vibration period of less than 1 second. Which tells us that, in the event of an earthquake, the resulting acceleration will be high. In this way energy is dissipated. Because the isolator's sliding surface has a well-defined radius of curvature, the building is allowed to increase its own period of vibration. Thanks to these properties, seismic accelerations are drastically reduced. This technology achieves the insulation of the base, while the damping values increase between 10 and 30%. Furthermore, the fundamental period could reach or exceed the value of 3 seconds. Most significantly, there is a reduction in the design seismic acceleration by at least 80%. The following figure shows the behavior of the same structure, with or without seismic isolation at the base. With the insulators, the acceleration demand is reduced, allowing the structure to behave like a rigid body, with less differential deformation, compared to the case of the structure fixed to the base. Let's look at some types of seismic isolators for buildings. Friction sliding pendulum insulators, with simple sliding surface. Friction sliding pendulum insulators, with double sliding surface. They have a damping between 10% and 30%. Rabbit and steel insulators with high energy dissipation capacity. They have a damping between 4% and 10%.
Apoya este canal, y aporta con tu like, o un me gusta. La mano con el dedo hacia arriba. Comparte el video, y deja un comentario con sugerencias para futuros videos.
Rabbit and steel insulators with lead core and high dissipative capacity. They have a damping between 11% and 28%. Damping systems. Damping systems dissipate energy when activated through the movement of the structure. What they do is reduce the dynamic response of the structure during seismic events. Structural and non-structural elements are protected by diverting seismic energy to these devices, which can be inspected and even replaced after a seismic event. In the following figure, we see the comparison of the behavior of the same building, without and with energy dissipation devices. This shock absorber type heatsinks can be viscose metal heatsinks and viscous frictional dissipators. Don't forget to leave a like.